All right, everybody. Hopefully you were able to absorb everything from the concrete lecture. Absorb. Yeah, there's some sparseness today. Maybe the mixed design example scared everybody away. Okay, your lab for the mortar cubes and the bicat penetration, as well as homework assignment number 4, are due on Tuesday. I imagine that homework that lab is largely done. It should be pretty straightforward. Your homework, though, is probably the one that takes a little bit of work. I got a couple questions that I thought were really good, and I thought I would address them just with everybody. So before I do, though, one thing I will say, everybody should have a mixed design handout. If you are missing one, I have extras in my office, so just come by. I'll probably set them outside my door in case you'd like one. And just so that it's clear, because I think I mentioned this during the example that we did on Tuesday, you do not need to waste space on an exam 2 formula sheet with that guide, okay? You will have that on the exam. So don't worry about that, okay? Now I got 2 questions about the mixed design that I thought were really good, and let me know if I miss anything, okay? So first off, one of the questions was sort of about the relationship between step 1 and step 2. So I'll answer it generally without getting into hyper-specifics, but in step 1, you compute a required F sub CR prime, and then you use that value in step 2 to determine a water-cement ratio. Okay, now in the example that we did in class, we used table 7.1 to determine our water-cement ratio, and then table 7.3 and 7.4 were sort of checks on it that ended up not governing. But it is entirely possible that they do. Like it's possible that you determine a water-cement ratio from table 7.1, but you actually don't use it. You end up using the one from table 7.3 or 7.4. That's completely fine, okay? And then the other question is, doesn't that change your FCR? Yeah, and that's fine too, okay? So, for example, and I'm trying not to spoil too many numbers, but I'll say this. Let's say you have a somewhat low F sub CR, and you get a water-cement ratio, and then you end up dropping that water-cement ratio a little bit based on this. That, in turn, increases your F sub CR. There's nothing wrong with that, okay? In fact, that's what it should be. I mean, if you're dropping the water-cement ratio, your FC prime should go up. So that's what's happening, okay, and that's okay. So if that gets adjusted, or if you end up using table 7.3 or table 7.4 for your water-cement ratio, and you end up not using this value, are you doing anything wrong? No, it just means that's how it works out. The second question I got was, I believe, about, which step was it? It was, might have been about the water, the weight of the water in step 6. So in the problem, I wanted you to assume angular aggregates, okay? So the question was, what do you use out of this table? And the answer is nothing, okay? The idea is that these water weights are reported for angular aggregate. If you have subangular aggregate or rounded aggregate or what have you, you look up here and then correct based off this. This is your adjustment. But if it's already angular aggregate, there's nothing to adjust. So what do you use here? Nothing. Okay? Does that make sense? Okay. Any questions on that? I'm hoping that the mixed design is a fairly straightforward process. I mean, yes, you have to, not every, value that we reported from the example that we did in class is going to mimic what you do on the example. For example, we used this, hold on, let me scroll up here. So in class, we used this. We used this because we had subangular aggregate. On your homework problem, you're not going to use it because you don't have subangular aggregate. You have angular aggregate, okay? So there are some differences, and that's I want you to work through those on the homework. Okay? Everybody okay with that? This is good stuff. Has anybody else looked at it? Anybody have any overarching big ticket questions about the mix design? Okay, good. If you have any questions, let me know. So this is probably our trickiest homework assignment in the semester. So I expect it to be a little bit challenging, but that's okay. So if you can get through this, you can definitely knock it out. All right, everybody get the code. Okay, today is a movie time day, okay? No real math or formulas or anything like that. It's just going to be me talking about placement. Basically, let me give you sort of the spirit of what we're going to be talking about today. I just want today to be an informational lecture about all of this, okay? So, and I mean, that's not to say what we're talking about isn't important, because it is, because I'm going to be talking about things that we are going to be doing in lab, okay, namely slump and things like that. But what I'm essentially wanting to do is recognize that what we have been talking about in class, so like that whole thing that we did Tuesday and what you're doing on your homework assignment is step one. That's the mix design, okay? So at the end of the day, you have a job, you have a targeted application of a batch of concrete, be it beams in a building, columns in a building, slabs, pavements, what have you. You have a required compressive strength, you have exposure conditions, aggregate data. You take all that and you develop a batch, a mix design, a proportion of gravel, sand, cement, water, any admixtures for the job at hand. You then test those batches, do trial mixes, do lab tests and whatnot. We'll do that together. But let's assume all that's done. You got a good workable batch of concrete. Now what? Now you got to use it, okay? So that's what we're going to be talking about today, is what happens when you're good to go, okay? So that involves batching and mixing the concrete itself, transporting it to site. You're going to sample it and do things like slump and cylinder and all that. You're going to place the concrete. We do not pour concrete. We place concrete. Pour the canoe. You place the canoe.
Why is pouring wrong?
It just is. It's just a term. It's not dirt, it's soil, you know. Precision in our terminology. It's just one of those things you got to get used to. We will then, once the concrete is placed, we will work to consolidate it. And so consolidating essentially means ensuring that all the voids are filled in the form with concrete. We might also talk a little bit about self-consolidating concrete, where we put super P in the concrete to make the concrete flow a little bit more. We'll finish the concrete and then let it cure. Okay? Let's talk a little bit about this. So batching and mixing. So batching essentially that process is measuring the proportions of gravel, sand, cement, and admixtures and whatnot, and then putting in the water. When we batch, we measure by weight, because weights are far more accurate than by volume. I mean, at the end of the day, the mix design that we produce, like when we had our final answer, gravel, sand, cement, and water, we did not report that final answer in volume. We didn't say you need 2 cubic feet of concrete, or 2 cubic feet of cement, and 6 cubic feet of sand, and 21 cubic feet of gravel, or something like that. It was just the weights. Weights are far less ambiguous than volumes. Even though we use sort of a volumetric approach for the math, at the end of the day, the weights are what's accurate. One thing to keep in mind is we are batching concrete, which is sort of why, like, in the mix design process, I mean, I was a little fast and loose with rounding. I'm saying let's just round to the nearest pound. It's concrete, okay? Rounding to the nearest pound is fine for your batching. I mean, just to give you kind of an idea, the scales that you're using to measure these components are not accurate to the gram, okay? They're accurate to within, you know, a couple points on a percentage, but I mean, it's okay, you know, if you're accurate within a pound and whatnot. A lot of this is done electronically. You just program it in, and the batch plant will do the work. One other thing that I should mention, I think I have a picture of this a little bit later. So the idea behind the batching and mixing process is your batch plant will proportion the ingredients, put it in your mixing truck, put in the water, and you start mixing. There is such a thing as a mobile batch plant. I think I have a picture of that on the next slide. Yeah, here's a mobile batch plant. This would be something that you would take to the site if you wanted to mix the concrete onto the site. There are a couple reasons why you might do this. For example, maybe you're casting concrete in a really, really remote location that's a good bit far away from your batch plant, and so you're worried about the concrete setting on the way. Maybe you're going to be using a batch of concrete that involves fast setting, and so when you batch it, you want to batch it, mix it, set it, and do it fast. So you'll actually do that on site. But I'd say the most common application is to have the concrete mixed in the truck. And I'm sure everybody here has seen a concrete mix truck where the drum and whatnot is sort of spinning as the truck is transporting the batch to site. Just curious, does anybody see from a construction engineering perspective the obvious difference between these two trucks? Just making sure people are paying attention on Thursday afternoon. One would deposit the concrete from the rear of the truck. One deposits the concrete from the front of the truck, right? So just something to keep in mind from a construction management perspective. Might seem like a silly thing to point out, but if you're doing a highway project on, well, let's see, there's 3 levels, for example. There's Wayne, out Wayne, and way out Wayne, So imagine, think getting the concrete to the site. I mean, it's even something as simple as getting the trucks turned around before you place the concrete. Something like this. I mean, if you're messing around getting a truck turned around, just something to think about, in terms of your construction management side of things. Okay, now let's talk a little bit also about the transportation side of things, and this also goes into placement. We're talking about transportation, getting the concrete from the batch plant to the site. There is also the aspect of how the concrete is actually placed from the truck to the form. I actually want to skip ahead a little bit and talk about that. Well, no, let's be formal about this. Before we actually place the concrete, let's not skip ahead too far. Before we place the concrete actually in the forms, we do need to draw samples from the batch to test them. Okay, this is a requirement on just about any, not just about any, like any construction job. You're going to pull samples from the batch of concrete and test them. Now, we're going to perform the full gamut of these tests in class, like the full range of them. And so those tests are going to be slump, air content, and temperature. The J-ring, if we do our self-consolidating concrete batch, that's the one with super P in it where it flows a lot better. So the slump test doesn't really make any sense. You sort of do an inverted slump test. But we'll do slump, air content, and temperature, and then we will also prepare samples for later testing. We're going to prepare 9 cylinders for each group, and so we'll test 3 at 7 days, 3 at 14 days, 3 at 28 days. We'll also prepare a beam prism. It's about yay big, and we'll load that in 4-point bending and whatnot, so to compute the modulus of rupture. So the cylinders will give us the compressive strength. This is sort of giving us the tensile strength. So that's how we'll get both of those. Okay, let's talk about the placing aspect, because this is where it can really, you can really get inventive, and you can really see different means of placing concrete on site. Now, when I mean placing, when I say placing, I'm talking about getting the concrete essentially from our mixing truck to the form. Okay, getting the concrete to its final destination. Okay, so a couple things to keep in mind. This is, at the time that you're placing it, it is a wet mixture of gravel, sand, cement, and water. So what you don't want to do is open the chute and just let it fall, 20, 30 feet. You want to handle it somewhat, with some care. You want to make sure that you're dropping you know, the vertical drops of your placements are less than around a yard. You also want to make sure that you're not being too agitating with your placement, because you don't want to, what you really want to make sure is that you're not getting excessive segregation. You don't want to get the aggregate separating from the cement paste. You want it all to be as homogeneous as possible, okay? Now, I mean, placement techniques can get from the super simple to the super fancy, okay? And super simple is the wheelbarrow all the way to some conveyor type systems, which I'm going to show here in a little bit. This is a power buggy. Basically, it's a motorized, essentially a motorized wheelbarrow. You would think that, like, with large-scale civil engineering projects, you really wouldn't use something like this, but you'd be surprised. For example, a project that I was doing some research on back in 2019 involved the placement of some ultra-high-performance concrete. And ultra-high-performance concrete is not batched in, like, tons and tons and tons of cubic yards. They're small mixes. We're talking about a yard or two. And so they're transporting them to the actual placement with this. I see you shaking your head, yes. Did they do the same thing on the site you were talking about? Yeah, same story, that they would just, you know, mix it and batch it there. And the mixing process is very unique, isn't it? So, that stuff will tear your hands up, won't it? Okay. Another means that you can place concrete is to use a crane and bucket. I'm curious if anybody who's ever been on a construction site, you've seen these. You've seen them, yeah. I've used these too as well. You can usually place about a yard at a time. A 3/4 yard bucket's pretty common. A yard bucket's pretty common. But essentially what you would do is fill this up with concrete, transport it to where it needs to go, and then this handle, you just whoop, and it drops down. Again, you're wanting to make sure that you're limiting your drop height to around 3 feet or so, and what have you. You can also just place concrete out of the back of the truck. So this works. It's really easy. Sometimes you can have access issues, and I'm going to show you a project out in Iowa where you can see how the access would be a little bit challenging. But, I mean, if you've ever seen a mix truck, I mean, you can unfold that end and it can just funnel right out. So, depending if your truck can get to where the placement's going to be, this might be fine. This would be a great, for something like a sidewalk placement or curbs where the road's already done, and all you have to do is drive the truck up to it, deposit the concrete, you're good to go. Where it gets a little challenging is when you've got really far reaches, okay, for your placement, and this is where things start to get a little inventive. So, for example, you can have a pumping truck type system where, you know, you can see here's the concrete truck that's come in with the batch ready to be placed. It deposits into this, and then it pumps it all the way out. The pumping truck also controls the flow rate. Oh, I'm talking about flow rates, and I'm bringing up the onset of acute post-traumatic stress disorder. Q equals AV. Stop talking about that, right? No fluid mechanics in here. Am I kidding or not? So I don't know. But yeah, so these pumping trucks can deposit concrete and place it at controlled rates. This was a project that I worked on. This was around, I want to say like 2016, 2017. This is in Iowa, and so the depositing technique was actually done with this conveyor belt. So the conveyor belt, I think I might have an image of this later on in the presentation. But essentially what happened is, so this was a casting of a bridge deck out in Buchanan County, Iowa. So we were like really like in the middle of nowhere per se, but it was not anywhere near like an urban environment. So what would happen is, you know, we're casting the bridge. There is no bridge for the trucks to cross, right? So the concrete trucks would show up. The batch would deposit onto this conveyor belt system, and then essentially the concrete would be conveyed along this extended boom crane, and then it would be placed right here. It was really simple, but it was really slick how they were able to deposit and place a lot of concrete in a very short time. this crew was really like a well-oiled machine in terms of this placement. It was very, very impressive. It was also, I mean, just like the extension on this crane. I mean, this thing was extending out probably like 80, 90 feet or so with like wet concrete cantilevered on it the whole way out. And I mean, just the forces on it was really, really impressive. Okay. Once the concrete is placed, we also need to level it out. Sometimes, depending upon the placement procedure, or maybe specifically the product that we're placing, we can sort of like combine placing and finishing kind of at the same time. So you'll see this in long continuous casts for things like road projects, maybe slip forms on jersey barriers on DOH projects. Has anybody ever seen those where they're sort of like casting the concrete parapet as the road goes and whatnot? So you're essentially depositing the concrete and finishing it at the same time. In the case of a pavement type project, you'll have this sort of screw spreading mechanism where this screwing device is sort of evening out the placement of the concrete as it goes on, and then you'll have something like a bid well smoothing the surface on the top of the cast. Okay, after you've placed the concrete, you then need to consolidate it. That is a picture of your jerk of a structural analysis professor doing some consolidating for the specimens for his PhD. I really can't stand that guy. He's such a jerk. But yeah, so this was a fun day. I was casting some samples. These were beam specimens for my PhD research, and so they needed to be composite beams. So I was casting a concrete deck on top of them. So I was like in the lab, we were using the 3/4 yard bucket to do this. So there was a concrete truck that had pulled up to the back. We filled the concrete truck up, or the bucket up. The lab had an overhead crane, just overhead crane, did that. We placed the deck in, I want to say like 4 or 5 trips of the crane. So we actually had the concrete in the forms in about 25, 30 minutes, something about like that. But you'll see what happens when you place the concrete in the forms. It's not like a prismatic, even surface. It's sort of just goopy. I mean, it doesn't, there's rebar here. There's spaces that it needs to fill in, okay? And so once you place the concrete, you need to consolidate it, okay? The most common piece of mechanical equipment that you'll use to consolidate is a concrete vibrator. Basically, you'll stick it in for a couple seconds, it'll spread the concrete into the zones where there's air voids, there's trapped air voids and whatnot. If you've ever done any like casting of concrete in your backyard, the other device that you'll use for consolidation is the rubber mallet, right? You've got some forms, just tap the sides of the rubber mallet and the concrete will settle in. I'm sure that the rubber mallet approach was probably used for your canoe placement, am I right? Or maybe that's an idea. So, but yeah, like you also have to be kind of like careful using this thing. So like this device would be actually a really bad idea for your canoe, right? Because your canoe, so let's talk about the canoe. Again, I don't want this to be like I'm going to teach you how to cast your concrete canoe, but I do think it's actually a really nice learning tool. So for those of you that have, I know there's a few people in here that I recognize from doing canoe placement last year. So let's talk about your canoe mix and talk about ideas from last year that could translate to this year. So first off, I believe that the mix was a little bit dry. Wasn't it a little bit dry? It was very granular. It also was difficult to mix, wasn't it? Like you couldn't mix it all in one big thing. You had to mix it in batches. But the other thing is it's a very gritty, sort of pasty type mix at the end, right? If you were to use aggressive vibration, what would happen is all the aggregate would settle. You'd have the cement paste and the canoe would crack, right? So using this would be a really bad idea for that type of concrete. Whereas regular concrete that's got gravel, sand, cement, and water in normal proportions, not as big of a deal, okay? So just something to keep in mind. You still want to do your consolidation, but you just can't do it the same way. So, because again, the mix is different. So just something to think about. Yeah, this is the overhead image of that bridge in Iowa I was talking about. So you can see what was happening. They had a pretty slick operation. So what would happen is that the concrete trucks would come down this road. They would park down here. They had sort of a queue of them. The concrete would get deposited into this conveyor belt system. It would deposit out and start filling it. So what we had done at this point when this image was taken, this wasn't from a drone. This was actually just me getting in the van lift, just taking a picture like that. So this was an integral abutment, so you have a slab on top, but you also have the ends of the bridge encased in concrete. So the ends were filled, right? The slab was cast, and you can see right here what they're doing is they're filling in the remainder of that integral abutment. So like what had happened is it actually took quite a few pours to fill in this region right here, but once you got to the actual bridge slab, like it went a lot faster. So it was like, we'll fill in here, and then we'll start moving down the bridge, and it went pretty fast and whatnot. Okay, so this is about when they're probably around 75 to 80% done with the placement at the time I took this picture. Now what they're doing is they're doing the act of finishing the bridge, okay? So finishing the bridge involves ensuring that the surface is smooth once the concrete has consolidated and cured. Now, I say smooth, but smooth is actually not the correct goal at the end of the finishing operation. We don't necessarily want a smooth surface on top, we want a desired surface on top, okay? What do I mean by that? Your garage. If you have a garage and the concrete, or the floor is concrete, that's a smooth surface, okay? Have you ever been on top of a bridge deck, like walked on top of it? Is it smooth like your garage? No. It's got ridges, right? Because you need traction for the traffic, right? So what you're after is not a smooth surface, you're after what you want, okay? And so in the case of this, it's not that. It has a texture to it. For example, if you look at sidewalk placements, so for example, when they place a sidewalk, they will smooth out the surface, but then they also have essentially like a concrete broom that they will drag across the front that leaves sort of a ridgy texture on the top so that you don't slip. You know, the sidewalk isn't slick when you walk across it, okay? Now, another thing that's happening here that you won't see in a slab placement in a building is this device right here. This is sort of a mini bidwell, okay? So what this is acting as, this part right here, is it's being drug across the top of the surface, and it's sort of creating your near finished surface. Now, the interesting thing about this little part right here that they're dragging across is it's not flat, okay? If you actually look at the profile of this screeding tool right here, it's got a little bit of a bow to it. Why does it have a little bit of a bow to it? Water, right? When rain hits, or when water hits the top of the bridge, we want the water to drain off. If the bridge is just flat, the water's going to sit there, and that's no good. We want it to drain off. So the bridge, the cross-section of the bridge, has to have a little bit of a crown. And so what that is doing is it's creating that crown, okay? So it's not flat, okay? Now, that process is called screeding, okay? So in the case of the sidewalk, the little pad in your backyard, the large, you know, patio placement and whatnot, the most common way of doing that is to use some scrap lumber, like a 2x4, okay? And so essentially what you will do is you'll take it, and I found that the easiest way to do it is to sort of zigzag it, right? If you've ever, how many have ever done this before? I'm just curious. Zigzagging is the way to go, right? So you take it, you just sort of do that, and then to get your near surface, and then you'll sort of smooth it out with a trowel or something like that after, okay? There are other ways of doing this, more motorized methods of doing it. So you can see this is sort of a motorized or a mechanical screeding tool that you can see right here. So what I'll say is that the more fancy the tools get, the bigger the jobs are, okay? So for example, you can see some, this would be a screening operation that would be in a large industrial type facility where you're going to be placing a huge pad of concrete, and so you do need it to be relatively level. This can also get really, really technically interesting if you're dealing in a manufacturing setting where the floor has to be level, you know. So just something as simple as the screening operation is going to require laser alignment and things like that. But really the simplest tools for finishing are going to be your things like your bowl floats or just your hand trowels and whatnot. This is a bowl float. It's essentially like a big flat panel on a big old pole. I'll say this, bowl floats are a lot lighter than you would think. Like, I remember when I first started, I thought it was going to be really heavy. It's really not. It really can't be, because you want to be able to reach out and smooth that out. And so the idea is, if you were doing something like a bridge deck, you would first get it smooth and then place your desired finish at the very top. Really though, one of my regrets in my career is that I've never been able to drive one of those. It's just like fun. I mean, come on, look at that thing, you know. That just looks fun. I have never done that.
There's still time.
There's still time, yeah. You could, I really am a dork. Like, if you consider, like, my bucket list, you know, there's, like, people who want to skydive. I'm like, I just want to drive one of those things. Oh, my Lord. So yeah, these are not as common unless you're doing, like, a really large placement. These power float options, I've seen those used every now and then for flat slab placements and whatnot. Pretty easy to use and whatnot. Okay. All right, last step is curing, okay? And curing, really, when we use the term cure, what we're recognizing is that concrete mechanical behavior is not independent of time, okay? Concrete properties change as the concrete ages, okay? And so the first, few days is really kind of critical to ensure that the concrete behaves well over its design life, okay? So what we're interested in the curing process is maintaining the moisture and the temperature. It's one of the reasons why when we cast the mortar cubes, we put the sponge on top with the water, okay? Because we're trying to maintain the moisture inside the cube, okay? Temperature wasn't like really a big deal because the cubes were indoors, right? But on an exterior application, that's kind of difficult, okay? So it's one of the reasons why you'll see less concrete placements in the winter, right? Heavy construction activity is during the summer. And don't get me wrong, I mean, there are other reasons why we do most of our construction activity during the summer. I mean, of course. But, I mean, if we get temperatures that start to get into the freezing land, we can get ice crystals in our concrete, and that's no good, okay? We also want to try and maintain temperature because we don't want differential temperature between top and bottom. We can get, warping of the geometry of the slabs called curling and whatnot, and so we don't really, really like that, okay? Drying, if you dry it in air, the strength goes down quite a bit. So for example, if you look at compressive strength of concrete as a function of time, like if you just dried it out in the air versus curing it in a moist environment, you get a lot better performance, okay? So that's really what we're after. What our goals are with curing is we want to try and keep the moisture that's in the concrete locked in. We want to seal any surface that is exposed to the atmosphere. And if we need to apply additional moisture or heat or whatnot, we want to do that. For those of you that have been on DOH construction projects, I'm sure you've seen this done before, right? Where that white goopy stuff is sprayed, that essentially its goal is to sort of lock in the moisture and ensure that you don't get a lot escaping and whatnot. You'll also probably cover it with like a fabric, like a wet burlap is, I imagine that's probably been done on a lot of the projects you've been working on. They'll cover it with like a burlap or some sort of like cotton type material that's damped and whatnot to keep the moisture locked in. This was what it was like out on the Iowa project I was on after they sprayed the deck. So you can see there's that white goopy stuff they sprayed it. They then covered it with burlap and then soaked it in water to ensure that it cured properly and whatnot. You also might find a sealing compound placed depending upon the environment. It does prevent the water from evaporating, which is great. But sealing compounds can also retain some heat, which may or not be all that great. Just depends on the environment that you're in and what have you. It works. It's simple. It's fast in order for sealing and whatnot, and for trapping in that moisture. It's really fast. If you've got a concrete placement, you've got a lot of surface that's exposed. Using some sort of spraying compound, it's simple. I'll give you that. So. But yeah, you can see here some sealers. You can also use just like plastic sheeting and whatnot. Probably not as common for super big jobs, but I mean, it is happening and whatnot. We can also apply heat and add additional moisture. I don't really see us doing that a whole lot in a lot of casts here in West Virginia, especially on the outside. Stuff like applying heat and applying moisture, so this is the third method that you can use to properly cure concrete. But this is the type of thing that you'll see done in a precast plant, in a plant where they're precasting concrete products and shipping them out to site. So this would be precast panels, precast slabs, precast or pre-stressed beams, things like that. Great for if you've got a little bit more control in the environment. A little tough outside in the elements and whatnot. And this would be things like, like adding heating coils, applying steam and whatnot. Not very common, I would say, in the elements and whatnot. That was a lot of like high-level info, but I thought it was sort of relevant to just give you a basic overview of how concrete is placed. Okay. What I want to talk about on Tuesday is I want to talk about mechanical properties of concrete. I want to talk about the Young's modulus. I want to talk about the modulus of rupture. I want to talk about sort of what happens once we cast our samples, what we get out of them, and how those data points can affect design and whatnot. This is not a reinforced concrete design class, so I'll leave that to Dr. Zatar. But if you're in reinforced concrete design, which I think there's a couple of you that are, if I mention F sub R or F sub C prime, those are terms that you've heard before, and so we'll sort of talk about where those terms come from in the lab and whatnot. But that's it for movie day. Today was a short day, so I'm going to give you a little bit of your time back. That's all I got. I'll pull the code up, and I'll see you.